The student t-distribution is very similar to the standard normal distribution in the variable z. They have properties that they share, and of course they have properties that they do not share. The one property that they do share is that both distributions have a mean of 0. Both distributions are bell-shaped and symmetrical about this mean of 0. One property that they do not share concerns standard deviation or variance. For the standard normal distribution or z-distribution, remember that the variance is exactly equal to 1. You could also say the standard deviation is exactly equal to 1. For the t-distribution, or the student t-distribution, the variance, the standard deviation, is strictly above or greater than 1. Another property of the student t-distribution that sets it apart from the z-distribution is that it's based on something called degrees of freedom. It involves sample size, lowercase n, minus 1. If you are interested in learning more about this property and degrees of freedom, and how the t-distribution is not just one curve, but is a family of curves based on degrees of freedom or sample size, please read your textbook. The purpose of this video is to teach you how to read and interpret the t-table so that we can find critical values within the t-table, and thereby we can calculate confidence intervals using the student t-distribution, or t-intervals for the true population mean mu. One property that I stressed in class is the last property that says the t-distribution approaches a standard normal distribution as the number of degrees of freedom increases. You can also say as sample size increases, the t-distribution approaches the z-distribution. This is a calculus concept with the idea of limits. Please be familiar with the properties of both the z-distribution and the t-distribution, the properties they share, and the properties in which they do not share. The formula from your formula sheet involving a t-interval for the mean replaces the z with the t from the t-table and sigma with s, sample standard deviation. Sigma is unknown. To use the t-table to find critical values like t sub c, you will need to know the degree of confidence and you will need to know your sample size. Together, those two values will lead you to the correct critical value in the t-table. I will review this problem even though we did this one in class. Sample size is 16. Degree of confidence is 99%. We wish to go to row 15, degrees of freedom, not row 16, but row 15, and column 99%. You will see that your two fingers meet at 2.947. So I will place the t-table on the document camera. Oftentimes I suggest that you take another piece of paper to block off the row of your choice so that there's so many numbers in the table, you do not wish to go to the wrong row or the wrong column. I also said in class, for now, if it helps, to block out the 1-tail alpha and 2-tail alpha row, which that is used for hypothesis testing, which is test for the end of the semester, last test. Go to column 99% and row 15, and your two fingers meet at the critical value for a 99% t interval for the true mean, and you're working with a sample size of 16, this degrees of freedom would be 15, not 16. This would be your critical value T sub C. And obviously, you know from the formula, we need T sub C or T sub alpha over 2 to calculate the confidence interval by hand. What I would like to do for you now is the very first problem listed, number 2, in terms of a t interval for the true mean. Given the confidence interval for the true mean mu to be 6.17 less than mu less than 8.53, find the sample mean and the maximum error of estimate, or something called the margin of error. The answers are as follows. E is 1.1800 and the sample mean is 7.35. If you noticed, I did not say that this had to be a t interval. I did not say that this had to be a z interval for the mean. The way this type of problem is set up, and the way they give us the confidence interval, so that we work backwards to find the margin of error and the sample mean, it does not matter if it's a z or a t, but you will find these types of problems within your textbook and within your homework. To do this type of problem, what you do is you write down what's given. You know that your confidence interval for the true mean, if it's a z or t, it doesn't matter, is already calculated to be 8.53 as my upper and 6.17 as the lower. They wish for us to find the sample mean x bar and the margin of error E. If you recall, when we calculated the z interval for the true mean, and when we calculate the t interval for the true mean, we may be able to reduce the formula to x bar minus E, x bar plus E for both the z and t. Going back to the formula sheet, the reason that I'm able to do that is when it's a z interval for the mean, E is z times sigma over the square root of n. You subtract it, you add that. So x bar minus E, x bar plus E. When it's a t interval for the true mean, E, margin of error, is t times s over the square root of n. You subtract it, you add it. So the formula reduces to x bar minus E, x bar plus E. For this particular problem, it is very helpful to see that that is the formula. In other words, x bar minus E is equivalent to the 6.17, and x bar plus E is equivalent to the 8.53. That will help you to understand how to find the sample mean and the margin of error. Since we know our confidence interval, and they ask us to find x bar, and they ask us to find E, one thing, if you remember, that you could do is find the confidence interval width. And I highly suggest you do that first so that you see that 8.53 minus 6.17 is a difference of 2.36. The confidence interval width. E is the confidence interval width divided by 2. .18 is exact, but because we give E to 4 decimal places, I included 2 additional zeros as placeholders. With a traditional confidence interval problem, I would not wish for you to use this to give me E, the margin of error. With this type of problem, the only way that you can find E is to use this formula. Let me explain. When you work your traditional confidence interval problem and I ask you for the margin of error, if you think about the template, for example, when we worked with Z intervals for the true mean, E was Z times sigma over the square root of n. And now that we're working with T intervals for the true mean, E is T times S over the square root of n. Those are the formulas that you should be using when you can use them to give me E, the margin of error. You can use these when they give you standard deviation of either the sample or the population, the sample size, and you know the critical value based on degree of confidence. For this problem, you cannot use either one of these formulas because you're not given enough information. They only give you the final answer in terms of the confidence interval, and we know it's a confidence interval for the true mean. We are not told if it's a Z or if it's a T. We are not given a sample size. We are not even given a degree of confidence so that we know the critical values. So for this problem, the traditional way of giving E cannot be done. You will have to use the confidence interval width divided by 2 method to receive E. So E is 1.1800. So we have been able to verify that. Now let me show you how to verify that the sample mean is 7.35. The sample mean is going to be the average of the 6.17 plus 8.53 divided by 2. It is the average of the lower and the upper. 6.17 plus 8.53 divided by 2 is 7.35. And I'll give you that number. 14.7 divided by 2 is 7.35. Check. Check. And we're able to verify that the mean is 7.35. Now, let's verify that this is true. If I take a blank piece of paper, and I know that x bar minus E less than mu less than x bar plus E, I know this lower number is 6.17, and I know the upper number is 8.53. Let's plug in for the E and the sample mean that we found to verify that we indeed get those numbers back. So this is basically saying x bar minus E gives us the lower, and x bar plus E gives us the upper. We found the sample mean to be 7.35, and we found E to be 1.1800. Check it out. When you subtract on this side, do you indeed receive 6.17? And when you add x bar plus E, do you indeed receive 8.53? Therefore, our answers are correct. The sample mean would be 7.35 and the margin of error would be 1.1800. And I will show you the calculator. 7.35 minus 1.1800, and then 7.35 plus 1.1800. Please remember this technique. Whenever you have a problem that is set up like this one, and they know that the confidence interval result is, given, in this case it was 6.17 to 8.53, that's all they give you. They don't give you the degree of confidence, the sample size. They don't give you the sample mean. They just give you the final answer, and they tell you the parameter is mu. You can find the point estimate, the sample mean x bar, and the margin of error if you remember these two formulas. E is the confidence interval width divided by 2. And x bar is the average of the two numbers they give, the lower and the upper. So I added those up and I divided by 2. So x bar, this may help, is the average of lower and upper, all divided by 2. I guess that's incorrect. Forgive me. I will just say that, let me mark through this. Let me give you a general formula. First of all, E is confidence interval width divided by 2. So you have that. So if they give you a confidence interval, then find the width and divide by 2. X bar, this is a better way to say it. It is the lower number plus the upper number divided by 2, which ends up being the average of the lower and upper when they give you a confidence interval. And in this case, they gave us 6.17 less than mu less than 8.53. And that concludes problem number 2. Here's a general formula for E, and here's a general formula for X bar. Lower and upper. Average of lower and upper. This is the confidence interval width divided by 2. One more time, I would like to stress that when you have a typical confidence interval problem, when it's not like this, they give you a lot of information, all the information you need. You should be calculating the margin of error this way with formula. But here it is impossible because there's not enough information to calculate E by formula this way. The only other way is this formula. Question number 3. Question number 3 is a T-interval problem, and it also happens to be raw data. Consider the SAT scores for 12 high school seniors. Find the 99% confidence interval for the true mean mu. Calculate X bar and S from the raw data above. Round those answers for X bar and S accurately to the nearest tenth, and then use them to find the confidence interval. We will verify in the video that we will receive the sample mean of 1764.2 and sample standard deviation of 252.4. If you have to do this by hand, you will need an X column and an X squared column and the total of those columns to plug into the sample standard deviation or sample variance formula. We will also verify all of these numbers. So basically, everything below in this space that is what we're going to find together in this video so that we receive our final answer for this word problem. I'm going to begin by putting my data values in my L1 column. I will not be using the formula to find these by hand. I prefer to use the TI 8384 calculator. So let's see if I can do this so that I can see the numbers. 1700, 1940, 1510, 2000, 1430, 1870, 1990, 1650, 1820, 1670, 2210, 1380. I highly suggest that you go back over the numbers. I feel like maybe I made a mistake, so I'm going to go back over my numbers. 1700, 1940, 1510, 2000, 1430, 1870, 1990, 1650, 1820, 1670, 2210. I made a mistake. And the last one is 1380. Very good. Once you have your values in the calculator, I'm going to go back to Stat, arrow over to Calculate, and press Enter on number 1 variable statistics. And I'm going to call up my column. Remember, this is all Test 1 material, so you should remember how to find this using your calculator. This is raw data, so I do not have a L2 column or a frequency column. So it should just be L1. Enter. You can see that the sample mean is 70.9 and the sample standard deviation is 2.8. This means I did something very wrong. Let's go back to Stat and edit. I did something very wrong indeed. I placed my values in the L2 column. I thought I was working with L1. Please excuse me. Now that is the problem, we'll arrow over to Calculate, and I'm going to change this to L2. So I placed my SAT scores in L2 column, not L1. And that's okay. Again, there's still no frequency column F, so I leave it blank. Now we should have the results we're looking for. 1764.16 repeating, and S is 252.35, 10662. That is what I did ask for you to do to verify here and here. The reason we round to the nearest tenth accurately is because Chapter 2 tells us when our raw data values are whole numbers or whatever they may be, round an additional decimal place accurately. So we will round these calculations to the nearest tenth accurately since our raw data values X are whole numbers. So this is coming from Chapter 2, Rounding Rules, Test 1. And I'm going to use these rounded values in my calculations. Now that we have that information, I am going to go about finding the confidence interval for this problem. I will take a blank template and I am going to write down that we have N equals 12 SAT scores and X SAT scores is the variable. We were given raw data. I'm going to write down that we had to find the sample mean, and we're going to use the 1764.2. And we had to find S. And I guess I should use approximation symbols instead of exactly equal to. And we're going to use the 252.4. And with that, they ask us to find the 99% confidence interval for the true mean. Now going back to the word problem. Subconditions. Consider the SAT scores for 12 high school seniors. Find the 99% confidence interval for the true mean mu. Calculate X bar and S from the raw data above and round those answers to the nearest tenth. And then use them to find the confidence interval. If you noticed, with the way this problem is typed up in your lecture packet, the subconditions are not met. The subconditions are that my sample size is at least 30, or the population of SAT scores is said to be normal. Well, our sample size is only 12. This condition is not met. Nowhere in the paragraph do I see the statement that the original population of SAT scores happens to be normal. Thereby, this is what you will need to do. You will need to make this correction, and it's a correction made by Miss Manhart. You will add the statement, assume the population of SAT scores is normal. So let's pretend that was typed into the original problem so that we do have that subcondition met. And we can go ahead and continue and calculate our t-interval. Without me writing that in and changing this problem, we really could do absolutely nothing with this problem. We could not calculate any confidence interval. So why bother finding the sample mean and sample standard deviation? Now, what I'm going to do is I'm going to go back and I'm going to write in here that they tell us the population is normal. Now, why is this a T and not a Z? Is sigma population standard deviation known? Do they say anywhere in the paragraph, assume population standard deviation is blank? Let population standard deviation be blank. You can read this problem several times and nowhere, and when I say that, you block out the bottom part. This is the problem. You can read it several times and nowhere do they mention a population standard deviation. In fact, it says calculate X bar and S from the raw data, round those answers, and use them to find the confidence interval. So there is no population standard deviation given. You have to find S, sample standard deviation, from the raw data. And thereby, this is a T. And I'm going to write that here. This is a T interval for the true mean. And the main reason is sigma is unknown. They ask us to find S, and we did find S to be 252.4. Going back to the calculator, S, 252.4, X bar, 1764.2, rounded to the nearest tenth. Critical value time. Since we now know it's a T and not a Z, we need T sub C. We need to go to the column which indicates the degrees of confidence, and we are 99% confidence, they tell us, and then we need degrees of freedom. So this is going to be 12 minus 1, or row 11. When you go to your T table, block off row 11, not row 12, and go to column 99%. And then you will have your critical value, T sub C. 99%, row 11, 3.106 is the critical value, T sub C. 3.106. Be very careful. If you accidentally go to the sample size N and not degrees of freedom, you will give me critical value 3.055, and that is wrong. Do not go to row N. Go to degrees of freedom N minus 1, which is 11 for this problem, and that is your critical value, 3.106. Going back to our problem, our work, remove the table. We can fill in that this is 3.106. If you notice all of the values in the t-table, the t-values, they are given to 3 places. And obviously it does indicate that they're positive. T-values can also be negative, but I will not talk about that until we research and we study hypothesis testing. And we're going to conduct something called a t-test for the mean. And that will involve negative t-values on the t-axis. For now, we're just working with that positive t sub c critical value found from the degree of confidence and the row in terms of degrees of freedom. Also, as a reminder, I, as your teacher, if it is a t-interval for the mean, I cannot ask you for any other degree of confidence. It has to be 80, 90, 95, 98, or 99. I cannot ask you for a 96%, a 94%, a 92%, a 85% when it is a t-interval for the mean. These are the only ones I'm allowed to use when it's a t-interval. I say that in opposition when it is a z-interval for the true mean. I can ask you for a 92% or an 85% or a 96% when it's a z-interval for the true mean. Margin of error. E is t times s over the square root of n. So that's 3.106 times my 252.4, all divided by the square root of 12. And we're going to plug that into the calculator. Some of you may struggle with this calculation. 3.106 times parentheses 252.4 divided by the square root of 12. So I was able to plug it in all at once. Enter. To 4 places, that is 226.3081. And I'll write that down on the paper. So there's the margin of error. Formula. I am going to write it down because we need to know that this is a t and not a z. But when I go to show my work in terms of formula, I'm going to do x bar minus e and x bar plus e. Therefore, 1764.2 minus e, which is 226.3081, less than mu, less than 1764.2 plus e, which is 226.3081. So I subtracted e and then I added e. 1764.2 minus 226.3081. That number is 1537.8919, and while I'm here, 1764.2 plus 226.3081, 1990.5081. And I'm going to write down both of those numbers, lower and upper, and then round. But I want to write down exactly what the calculator gives me. So here in this spot, you should write 1537.8919. And in this spot, you should write 1990.5081. In this box, I'm going to put 99% confidence interval. Now, the textbook says rounding rule to round to the same number of places as the given sample mean. This rule. Well, they didn't give us a sample mean. We had to find a sample mean and round the sample mean to the nearest tenth because our raw data values were whole numbers. Thereby, if our sample mean is given to the nearest tenth accurately, we will round our final answers also to the nearest tenth, just like our sample mean, accurately. 1537.9, 1990.5. Final answer, by hand, using a rounded sample mean, a rounded sample standard deviation, a rounded margin of error. So we did quite a bit of rounding throughout to do this by hand. But this is how I'll make out your quiz and your test in terms of answer choices. If it's a raw data problem, I will use the rounded values for X bar and S according to my raw data, which are whole numbers. I will then use those to find E, and then I will round E to 4 places. I will use the rounded E in the calculation, and then I finally will round according to my sample mean, which I had to find, and it was given to the nearest tenth. Well, not given, we found it and rounded it to the nearest tenth because our raw data values were whole numbers. And this would be 1537.9 to 1990.5. Then confidence interval width. I'm going to use my final answers, which have been rounded, to get that difference. 1990.5 minus 1537.9, and that is 452.6. 452.6. Going back to the worksheet, we can verify these values. By hand, we calculated E to be 226.3081. We found the T from the table. By hand, with the template, we found 1537.9 to 1990.5 by hand. And that's the answer you will choose. Now I have to discuss something that is a little bit of a, I guess you would say controversy with the TI 8384, stats versus data. They slightly disagree when you use your TI 8384 calculator. So clear, go to stat, arrow over to test, and go down to number 8. Even though this is a raw data problem, and I'm given the raw data, I personally feel like it is better to calculate it as a statistical problem. When you calculate it as a statistical problem instead of a raw data problem using the TI 8384, it will match up with what you calculate by hand with a basic calculator. If it doesn't exactly match up, it will be more closely match up with what you do by hand. The thing is, when you go to give the sample mean, you need to put in 1764.2 and then 252.4. Sample size is 12, and the degree of confidence was 99%. This will allow the TI 8483 to more closely match up with what we did by hand and template with a basic calculator. You see you have 1537.9 to 1990.5, and that is exactly what we got by hand. Now I'm going to go back to stat, and I'm going to go over to test and go down to number 8, T interval, and press enter. And calculate it, arrow over, and calculate it as a raw data problem, which it is a raw data problem, and press enter there while it's blinking. I did not put my list in L1 like you would as a traditional student or a new student of elementary statistics. I put my data in L2 because my L1 column was occupied. But whatever column you decide, make sure that is the column you put your raw data in at the beginning of the problem. Frequency 1, just leave it 1. Don't delete it. Don't clear it. Scroll down to 0.99. Leave it 99% because that was our degree of confidence. And then press enter on calculate. If you notice, you get 1537.9 for the lower, which agrees with what we did by hand, and it agrees with what the calculator just did when we treated it as a statistical problem with a rounded sample mean and a rounded standard deviation. But the upper, 1990.4, is not what we got by hand, and it's not what the calculator just gave us when we treated this as a statistical problem with a rounded sample mean and a rounded standard deviation. So treating it as a raw data problem makes it not match up exactly with what we got by hand. And that is the conclusion of problem number 3. That also includes any T interval problems that I would like to show you in terms of lecture. The next page or next lecture will be concerning proportion Z intervals for true population proportion. Hopefully by watching the video on T intervals for the mean, if you have any questions whatsoever, you may ask in class the next time we meet. Thank you so much for being patient and listening to this video.